Hey, we have here another problem. This one's from MIT 2011. I've got the integral of secant to the fourth x tan squared x dx. Okay, this doesn't really look like a contest problem. This is actually just a really standard integral that you get like when you're taking Calc 2 or like your initial calculus class. Okay, typically when we have an integral of secant and tangent, the thing to be aware of is that those two work really well together, and so let's look at the derivative of tangent and the derivative of secant real quick. Okay, so we have these two derivatives here that we're working with. And so I think what we're heading for with these two derivatives is, can we make a u substitution and somehow make use of the derivatives? What if I made my substitution for secant? What if I made u equal to secant of x, right? Well, it kind of works because, okay, we have secants and we have tangents, but you'll notice if we just pull out a secant and a tangent from this, we have a tangent left over, and I think it's going to be kind of awkward. So what I want to do is look at this the other way and look at what happens when u equals tangent of x. So if u is tangent of x, derivative of tangent x is secant squared x. Well, we can pull a secant squared x out of this, and I think we can make this work. So let's just, before we make a substitution, let's actually just write it that way. So what I'm going to do is I'm going to pull a secant squared x dx out over here so that we have potentially our du over here. And then we're still going to have a secant squared here out front. Noticing secant squared times secant squared gives us our secant to the fourth. And we're going to have this tan squared x over here. So then if we want to make this substitution, we're doing pretty good, because this will be like u squared, this will be our du. But what about this secant squared? Well, we can use an identity on this. So now if I use this to rewrite it, now we're going to have everything over here is going to be in terms of tangent, and then our du is all set up. So let's see how this is going to look. Okay, and now with this rewrite, I think we can do this u substitution, because we have everything over here in terms of tangent, and we have our du. So let's make this substitution. So for this first part, we're going to have u squared plus 1 times, here's going to be a u squared. This is going to be our du. Then we'll just multiply this all in here so that we're integrating u to the fourth plus u squared du. This is going to be an easy integral using power rule, right? So we're going to have u to the fifth over 5 plus u cubed over 3 plus c. We're just going to need to back substitute with our u, so we're going to back substitute here and here, and we're left for a final solution. We're going to have tan to the fifth x over 5 plus, here we're going to have tan cubed x over 3 plus c. That's it. Thanks everyone. Please subscribe. Have a great day.